Hello everyone, this is Jake Lawler, and we are going to be discussing velocity and other rates of change today in AB Calculus. So today we're going to be discussing two types of velocity. The first is enlarging objects, so we're going to be taking circles and possibly three-dimensional objects such as cylinders, and expanding them and then finding the rate in which the area is changing. And second, we're going to be finding the motion of particles, specifically when a particle is stopped. So how do we do this? Well, we find the derivative of the function in order to find the instantaneous rate of change. This is with any function we can do this. In this case, it just happens to be that our function is an area or volume function. So we have the area, for example, of a circle is pi r squared, and we take the area and find the derivative, which, using the power rule, is 2 pi r. And then that is going to be our instantaneous rate of change at a certain radius of the circle. And then we move over to particle motion. If we want to find a stopped particle, we can just simply find where the velocity function is 0. And this is simple to do unless, of course, you have only the displacement function, in which case you have to find the derivative. Also, you can find displacement by doing the opposite, by taking the integral of the velocity function. All right, let's do some examples. First, enlarging circles. Steve, in Minecraft, wants to build a circular base for his house. He wants to know what the rate of change of a base with area of about 500 blocks is. And he only has 500 blocks of stone to do this with. So we are going to have to round to integers, because those of you who play Minecraft know that blocks which are placed can only be used with integers. So we find the area, which is pi r squared, and we know that the area has to be at least or less than 500 blocks, right? So we go 500 equals pi r squared. Now this could be 500 is less than pi r squared, but for now, let's just do equals, and we can round it if we have an integer, or if we don't have an integer. So then we solve for r, and we get r equals 12.41. Well, what do you know? It's not an integer, as with 99% of circles. So we're going to round it to 12 by rounding down. All right, so we're back here, and we figured out that the radius actually should be 11 in order to stay under 500 blocks. This is just a weird quirk with Minecraft. So then we take the derivative of the area with respect to the radius, and that is 2 pi r. Then we substitute the radius of 11, and we get 22 pi. Okay. And so let's move on. Okay, we're going to deal with some 3D objects now, which is cylinders, yay. Steve, same guy, now wants to begin building columns for his house with pillars that are 12 blocks high. What is the rate of change of a volume of a pillar with radius of 4 blocks? So we're going to assume that this means that we're supposed to use cylinders, because that's the title of the slide. And so the volume of a cylinder is equal to pi r squared times the height. Well, what do you know? The height is actually not a variable here. It is a constant of 12 blocks high. And we can find the volume using pi times r, which is 4 squared times 12. Now let's find the instantaneous rate of change of the expansion of the volume of the cylinder as at 4. So we take the derivative of the volume with respect to the radius, and that is 2 pi r times the height, and that's equal to 2 pi times 4 times 12. We're just substituting 4 for the radius, 12 for the height, and we get 96 pi. So those are pretty simple problems. Now let's move on to some particle motion. Steve is now falling from a height of 150 blocks. Now in Minecraft, blocks are about 1 meter, so we have 150 meters. We are also going to assume that if he's falling down towards the ground, so he will eventually hit it what will his speed be when he hits the ground. And we're also going to assume that he's on Earth, so he's going to have the gravitational acceleration of Earth. And speed, when we're dealing with speed, it's the absolute value of acceleration, or of velocity, sorry. So we have our function here. It's, the displacement is equal to 150, which is the height of the start, minus 4.9 t squared. 4.9 t squared is a relation of the time to the speed in which he increases as he goes to his death. Okay, and so we can find the velocity function, which is going to be helpful because what will his speed be when he hits the ground? Well, we want to find what his velocity will be and then take the absolute value. So we take the derivative of it, power rule, and we get negative 9.8 t. So that was pretty simple. Now we need to find exactly what time he hits the ground. So of course that's just going to be when is the displacement equal to 0. Assuming, of course, that 0 is the ground. So 150 minus 4.9 t squared is equal to 0. Again, 0 is the ground, and we solve it out, and we get t is equal to about 5.5 seconds. And then we simply have to plug in 5.533 seconds into the velocity function for t, and we get 54.22 meters per second. Now, that's kind of fast. So let's see what it looks like.
All right, so let's just make sure we can see our coordinates, and we're going to fly up to 150 blocks. Do 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 do. At 100, you can see it on the left where it says block. Second down on the second row. Oh, we're at 154, 149, 150. Here we go. Okay. Game mode survival. Uh-oh.
Yes, so Steve died. Anyway, let's go over what we covered in this video. We enlarged some objects, so we took a circle and a cylinder and found the instantaneous rate of change for them, and at a certain radius, of course. And the instantaneous rate of change for them is the derivative of the area or volume function, which is really just the derivative of a function is the instantaneous rate of change, and for this it happens to be area or volume because we're dealing with geometry. Next, we dealt with particle motion. To expand on it a little bit, S of t is the displacement, V of t is the velocity, and that's also the first derivative of S of t, and acceleration is the second derivative of the displacement. And that is all, folks. Thanks for watching.